can you check if a type has a function implemented? For example, I want for my templates to use only types that has implemented two string functions.
Yes, this is true, and I will show you how you can add those constraints in requires expression, and you will see that how you can define requires expression. So, what's the syntax of a concept? Concept is expressed as a constraint, not template arguments. And here we define the concept living creature, which is a multicellular organism, or it must satisfy, which constrains the type T to satisfy the multicellular organism concept, and it also has a requires expression that requires that the type T has methods eat or breed. And this requires expression evaluates to a bool value, and it evaluates to true if each construct that makes it up is a valid C++ construct. There are also other rules that we'll see immediately. And how we can use concepts? We use concepts by constraining the type parameters of function templates or class templates. Here I present 4 equivalent forms of using the living creature concept that I introduced in the previous slide. The function, the first one that requires clause comes right after the template parameter declaration. In the third one, it can also come after the function declaration. We also have a terse notation where you replace a type name or class T from the template declaration with a concept name, and that means that the type T must satisfy the living creature concept in this case. This is called the terse notation. And the fourth form is actually a function template, even though it doesn't mention template anywhere. But it has a concept parameter, and you have to use auto keyword to tell this apart from types, as from other type non-concept types. Other uses of constraints are concepts can be used to constrain auto. So wherever you you have deduced type from for a return value, you can constrain it to be to satisfy a constraint or a concept, and then if the return time doesn't satisfy that constraint, the compiler will give you an error. Also here, if the return value of f is not a type that satisfies the number concept, you will also get an error from the compiler that the concept was not satisfied. I will go, these slides are a bit repeat what I told before. They just show you how you can define concepts by using a primary expression of type bool. This is very easy. Or by using a requires expression. The equality comparable concept is a concept which constrains its type to have the equals operator and the not equals operator and they all should, these operators should return the type bool. And this is just a very complex example from the ranges ranges library that will also be included in the C++ 20 release. And you can see that concepts can be defined using very complex expressions. Like you have here requires expression that and nested requires clause inside the requires expression. So this requires clause inside the requires expression need to be satisfied in order for the outer requires expression to be satisfied. This construct, for example, requires that the type T has a no except destructor. You can combine and you can also enforce relations between types. Here you can enforce relation between type T and size T, and you can constrain that the result of the address of operator is the same as the pointer to T, and so on. Okay. I don't recommend anyone to build their own concepts, because to get them right is very complicated, and I will come back to this at the end. You should use concepts from the standard library or from well-established libraries like the ranges library, like that. You should use concepts indirectly by using libraries written by more knowledgeable people. Okay, so concepts in action. In the first example, the sorting of a list, the error message or the diagnostic message from the compiler could be that the list iterator of int doesn't satisfy the random access iterator concept, and somebody who is not or is a beginner programmer can look up what random access iterator means. In this case, the implementer of some function gave a precious information to the user. It said that the type T must be a number. Now the user of some function can look up the definition of number and see that it's a type that has operators plus, minus, times, so on. And he can reason about the code. I think that the most important use of concepts is in overload resolution, in finding the most appropriate function for function overload and template specialization. The constraints representing the concepts form a partially ordered set that can be used by the compiler to derive the best candidate in overload resolution. How it's done? The compiler will try each candidate for overload in the order specified by this relation. The relation is can be called subsumes, in Romanian suma, or is more constrained than. Let's say, for example, you can say that dolphin subsumes the concept. Dolphin subsumes the concept of animal, mammal, vertebrate, toothed whale, or cute animal, and or that the concept dolphin is more constrained than the concept animal, because it's not so free. Okay. The order is partial, because not any two concepts have an order relation between them, and sometimes the syntactic requirements on types are the same. For example, for the input iterator or the forward iterator, the syntactic requirements are the same, exactly the same, but only the the forward iterator has a multipass property. So this is a case in which the programmer still needs to help the compiler to find the best overload. Okay, I'll give you an overload resolution example. Let's consider the problem of traveling and moving from one point to another, and we have some types. Some can crawl, and a few types can also fly. And we want to implement a generic travel overload set that takes advantage of flying. Overload set is just a set of functions having the same name but different parameters. Okay, I will show you which are our types, so you know from the start. This is a reptile can crawl, a bird can crawl and it can fly, and the spaceship can teleport and it can fly. Okay, so we start by defining our concepts. The concept, we define the concept creature that requires its type to satisfy, to have the crawl method, and another concept for airborne creatures, which can also fly, and they subsume the creature concept. So an airborne creature is a creature, so it must be able to crawl, and it also needs to be able to fly. And having our concepts defined, then it's very easy to write our overload set. We have the generic and slow implementation, in which we constrain the type parameter to be a creature to satisfy the creature concept. And in this overload, we call the crawl method, and we also have the optimized implementation for flying creatures. And in this implementation, we constrain the type parameter to satisfy the airborne creature concept, and then we can call the fly method because we know that all airborne creatures can have the fly method. These are the types you saw previously, and this is the test program. So the compiler will try the overloads in the order of their constraints. So in the first case, it will call reptile.crawl or the reptile crawl method, because reptile object doesn't satisfy the first the airborne creature travel method, which is tried first. In the second statement, the first tried candidate, which is for airborne creatures, is chosen, and therefore bird fly is called in this case. And in the last case, we got an error. Spaceship can crawl. And here we see type reduction being constrained by using concepts. So in this case, the compiler type checked the type parameter for us and gave an error because our travel overall set was actually intended only for living creatures and not for spaceships. If you have any question about this, yes, please.
About this ordering, subsuming ordering, how is realized by how does the compiler know that one concept is constraining more than the other and is more priority?
Just a second.
How do you tell?
Here, the airborne creature is subsumes the creature concept because it is defined using the creature concept, and it uses the conjunction using
So if one
creature.
writes without creature, just require will contain of crawl and fly, the compiler cannot deduce.
No,
subsuming.
and it will consider that the concepts are not cannot
related.
incommensurable. Cannot compare them. And yeah, I forgot to mention that the compiler does constraint normalization during compilation, where it replaces each non-atomic constraint by the atomic constraints by which make it up. Okay, so advice the C++ concepts were meant, I mean, especially Bjarne meant concepts to model semantic categories like same, number, function, iterator. These are very rich and full of semantical richness, rather than syntactic restrictions like addable or has plus. Many programmers consider that this is very limiting because, let's say, for a total in the order type, you have to have also less than equal, greater than equal, and so on. And programmers ask, why do I need to implement all these operators to satisfy the total order on my type? Because less than would be more than enough. So also I already told you that you should not create your own concepts if other made those before you. So always look up the standard library or other libraries if they have concepts for your needs. And beware that concepts are part of the interface of the function templates or class templates you write. So you need to be very careful, because if you change the requirements or constraints on your classes or functions, then you will affect your user base. I mean, the users who use your code. Also, currently, concepts and constraints on functions doesn't affect how the function symbols are generated by the compiler to the linker, but those actually work in most cases, and maybe that field will also change until 2020. Okay.
Why it's harder to design concept hierarchy compared to class hierarchy or types hierarchy? Why it's harder? What aspect of it?
Because, let's say, here in the equally comparable, here you have to remove the reference because otherwise you have a lot of side effects. And also, if in this example, if you define the airborne creature by requiring that A has also crawl and fly, and didn't use subsummation of the creature, then you wouldn't have done anything. So you need to be very considerate when you have to think very well how you want to use the concepts and how it might affect the code, your code or others' code.
So basically you have to think all the time about const and reference and decay and stuff like that.
And people who make compilers and libraries know better than that.
Agree with that.
Isn't that the same as with template? Because it's more or less the same thing. You design a function template, you have to think it can be a reference or a volatile or const or whatever.
For example, this this example, in order to have the subsume, you have to know that you have a creature, right?
Yes.
So it's the same with types. In order to not create, I don't know, the two types by inlining the same definition twice, you have to know that you have the other type, the more
Exactly.
generic one. So it's about knowledge.
Yeah.
What happens, for example, in this case, if you define the second concept without the creatures? So instead of, let's say, we have crawlable and something that can fly, whatever, and you have one type that has both functions. Is that a compiler error? Like
Yeah, the compiler should give you that it's an ambiguous
okay.
overload, and because both constraints are satisfied, and
Absolutely.
we'll get an error.
Can you define here not? So for example, a that crawl and not fly.
Yes, you can, and you can also use disjunctions. I used only conjunctions in
Okay.
examples, but because
I have a question. What would be the overhead, and not only mentally, like compile time wise? Like, does it make your time compile 10 times slower, or it's just somewhere in the 1-2 times slower?
I haven't measured, but I think that it slows down compilation. For example, you don't have operator shortcutting, like the compiler will check all the constraints concepts during constraint normalization, and I think that compilation time will increase using this. But I haven't. For these examples, you don't see any difference. By the way, these features are supported from GCC version 6 or above, using a -f concepts flag. And I think that also C-Lang has a fork that has this implemented. In GCC, you need to write something like concept bool, but they will remove that right now because it's not standard. Okay, so that would be it.
Just a last question.
Okay.
Do you know why they pushed that much the concepts? What were the main difficulties?
I don't know. It was a personal ambition of Jan, and
Probably they
and
wanted to lay all
he has
the
a problem
pieces.
that everybody considers the C++ very difficult, very hard, and he thought that concepts would make it easier. I mean, template programming and better diagnostics, compile time diagnostics would appeal beginner programmers, and and also you have
Actually,
these.
Alexander Stepanov wanted the concepts in the standard library for about 30 years or so.
A lot of patience there.
Most of the things could be done using enable if. So
Yes.
So it seems that they move the complexity from the declarations to the definition of the concept somewhat.
but it makes it easier to write after. So you define a concept and it's cleaner
Yeah.
after you define the concept with enable if. Even after you define, let's say, the constraints, it's difficult to use it later. To check if a function is present or that has some properties to enable it. Complicated.
Okay, so thank you very much.
So I think we'll have the next presentation and then hope the food arrives in the meantime. No? Or do you want to take a short break? I think.
Maybe it's a good idea just to do 5 minutes.
Okay, let's do a 5-minute break and then we'll yes.
Okay, so can we continue? Show dominance. Today's talk will be about guideline support library. This is my first presentation, and what the presentation will consist of, few problems will be presented that could arise during our daily programming life, and a potential solution will be presented by the GSL. So, who heard about the guideline support library? Yes. And who heard about the GSL? Not so many people. So that's why I want to present GSL for you. And let's dive in. And I would like to tell a few words about myself. Well, it's not working. Okay, I'm Attila Tóth, and I'm a junior C++ developer at Qubis. In my spare time, I like producing music, hip-hop, playing basketball, and traveling. Okay, let's start with the code by Ernst Russell. Well, C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do it, it blows your whole bag off. So, GSL could be the solution to avoid these problems. Okay, so what is GSL? But before we'll talk about GSL, I want to present the guidelines for those who haven't heard about the guidelines. The guidelines are a set of rules, guidelines, and best practices in C++, which aims C++ developers to write better and more modern C++ code. And then the GSL. So it is a library for supporting these rules provided by the C++ guidelines. It has helper functions, types, and classes that could help us in our programming life. Let's see, what does the GSL contain? It contains owners, utilities, views, contract support and conversions, and concept. But since Robert covered us earlier, we won't getting concepts covered. So let's start off with owners. Well, as you know, an owner is an object that manages a resource lifetime. And let's start with a code snippet. We have a complete function that allocates a resource on the heap, and it uses it, then returns it. Can anybody tell me what could be the problem here?
Memory leak.
Yes, a memory leak could happen. Well, the problem here is that we don't know who deletes the allocated resource. So there is an owner alias template in the GSL that has ownership of the referenced object, and the key here is to delete memory explicitly. And owners are used when you are working with either older code that has ABI compatibility, or you cannot use resource handles such as smart pointers. So you could ask me, why would you use owner instead of row pointers? Well, there are some analysis tools called lint tools that check your code if you either returned the allocated resource, so you give the ownership to another owner, or if you deleted it. If you don't do this, you forget this, then you'll get a warning by the analysis tools. We'll cover the analysis tools later on in the project.
So
In
it's
the
only for
presentation.
static analysis, it doesn't have, it's just a blank template that marks the pointer as.
Sorry, once again?
So is this a blank template just for marking the pointer, and static analysis uses this for?
Exactly, it's
Okay.
only an alias template that gets as template parameter a pointer. It uses std enable if, and it looks if with std is pointer if the parameter is a pointer. Yes?
Why would anyone return this owner instead of a unique pointer?
Yes, as I mentioned earlier, well, if you cannot use resource handles as smart pointers, or you are working with older code that has ABAC compatibility, then you could use owner.
Also, what if you just reset the pointer like a douchebag and then give the pointer back?
Sorry?
What if you reset the pointer?
I'm talking about this explicit case.
Yes, but why don't you return a unique pointer? Because unique pointers are not foolproof in that case. Like, you can mess with the unique pointer. You can mess with the resource if you want to. Behind the covers.
In this case, it's not clear what's the purpose of owner. So what's happening with owner when it goes out of scope?
Well,
It's something, or
another
Just bookmark for the
so just
static
mark.
analysis.
So we still have the leak. It's not solved.
Yes.
But this is not the place where you should delete it. That's the idea, because if you return a unique pointer, then it's gonna be destroyed when it's gonna be destroyed. The unique pointer. The owner is gonna follow through the entire program who's the owner, and if at some point you want to mess with it, it's gonna warn you. I think that's the main idea behind the lifetime proposal, because this is part of the lifetime proposal. This is not the place where you should delete it. But if you want to return a resource, then you should mark it. Like, who owns it? Make it clear, that point. And also make it hard, because otherwise there's only a convention. Like, if you return a pointer, then somebody has got to delete it. This way, it's actually enforced. Like, it's gonna warn you, or
Okay, so owner just moves the pointer. You don't have two owners pointing to the same stuff.
Doesn't move anything.
It doesn't move.
Marks that you're transferring ownership, but the underlying is just still a row pointer.
yes, it doesn't.
It doesn't move anything.
Yes,
It's only an
So you
alias
still
template.
have this ambiguity in the implementation.
It's just
Okay.
for static analysis.
Yes.
That's all.
Yes.
I understand static analysis. So in this case, owner, you could have A and B point to the same object and call two functions that both get an owner, and since they see an owner, they can delete it. So you still have
They
this
need.
ambiguity.
Yes, but somebody needs to delete it if it's an owner. Otherwise, if there
Yeah,
are
but it
owners,
doesn't solve too much. If you can-
Doesn't want to solve anything, it just wants to signal that you are transferring ownership outside of the function.
yes,
Doesn't want to solve anything, no, it's not an RAI, nothing. Just
Yes.
transferring ownership, and it marks it that it's being transferred. That's it.
Okay, so any other questions? Then let's move on. Well, smart pointers, they are borrowed from the standard library. So in the GSL, there are only aliases for the standard unique pointer and shared pointer. And then let's move on to the next topic, where we have utilities. Well, let's take a look at an example. We have two functions. The first function calls the second function, which does something with the pointer. So what could be the problem here? Could anybody tell me? So anytime we call the functions, a check will be made. So there we get branching, and in GSL we have not null. It is a template class that restricts a pointer or smart pointer to only hold non-null values, and there is only one check made. it can be constructed from null pointer or can it be assigned null pointer. So our second utility is finally. It is used to clean up things, and it's used for either begin end functions, flag setters, or resources that doesn't support try. So we have an example here. We want to open a file with the good old fopen. We use the file, then an exception is thrown. And after the exception, and at the end of the function there is fclose, but since an exception is thrown, the file never gets deleted. So GSM introduces finally. Finally returns final act object, and as a parameter we can provide finally a lambda function, and upon destructing this final act object, the object's destructor will be called. That will invoke the given lambda function. So even if the exception is thrown, upon exiting scope, this lambda function will be called. So the file will be closed. Okay, then we have the third.
What if it throws while trying to create the
It's just
the
a classic
object
scope.
trying to destroy?
It's just a classic scope word, so we just
But I imagine some memory allocation happened behind that function.
No, it's a dumb function, so
it has a parameter, so it captures something. So it's
Yes.
a more complex type, not just a plain
Big.
function.
yes, it's a more complex type, but it doesn't. It just assigns it, so it's a function call actually, because it passes fp as a parameter, but that would be like a local function, I think, in this case. That is a good question. What happens if it fails? It's just gonna throw.
Who's going to fail?
Finally
construction
creating
of
the,
finally.
so right now we have the fopen succeeds, returns the, I don't
The
know,
lambda that captures that.
file pointer, and
Yes.
finally has to create some object.
It creates a
somehow.
final act object.
Yes, which is on stack.
The move constructor
If,
from fp.
if finally somehow can fail,
Yeah, but that's
then
so. In this example, nothing throws except that last throw.
maybe finally throws. Maybe
Finally
does
cannot
a
throw.
New,
Yes, not true.
new function, new operator for, I don't know.
It doesn't. It's just a simple
That's
stack.
the assumption.
So probably it just moves the lambda inside some interval variable.
But lambda has some dynamic allocation there because
Yes.
probably finally accepts a std function as a parameter.
No.
Yeah.
Isn't that an std function?
No, it shouldn't.
But it should
It
be an
should
std
be. It
function.
should be a template there.
Yeah, I mean, maybe that auto is a more
Okay.
complex type that we
If it's an std function, yes, it will throw. But it should be. I haven't looked at the implementation, but it should be a template.
I can check.
They'll be really dumb if they won't make that a template.
Okay, the third utility is index. There are three examples of a for loop. In the first example, the loop variable is an integer. What could be wrong with this approach?
The size is odd.
Sorry?
If the size is odd, it's not even.
Yeah, the main problem here is that int may not be enough for the vector size. The second example is the same, since auto will deduce the type as being an integer, and the third example, we may risk a wraparound there. So we might use index. Its purpose is to avoid signed and unsigned confusion and pitfalls with auto and int. And here it's guaranteed that index will be able to iterate over the vector. Since behind the scenes it's a pointer div t that's signed, and it guarantees that can hold a pointer's size. In the second code snippet, I want to store the distance between two iterators, and that's why they wanted it to be signed, since we can make pointer arithmetic with pointer diff-t, and so we can store signed values. Then we have the views. We have the span. In the past, it was known as an array view. It points to contiguous segments, and its layout can be interpreted like similarly to this. So we have a pointer that points to the data, and we have a length, a pointer diff-t, and I want to give you an example here. We want to print out an array. We have the array as the first parameter and a length as the second parameter. So what could be wrong here? What may go wrong here? So we could give the length. We can pass a length that is greater than the array's actual length. So we could access memory that doesn't belong to us, and strange things can happen then. Spans can really help us out in this situation when you are working with pointer plus length combinations, or and, or begin and end. So we rewrite our function. Now it gets a span, and we have a function that declared an array, and we pass the array. A span will be constructed from the array, and the size will be automatically be deduced from it. So then we can simply print out the array without giving size. The span has a bunch of convenience methods, such as size, that gives the number of elements, size bytes, that gives the size of the span in bytes. We can check if the span is empty. Add method that is like at the containers. We can use the square brackets here, and then data that returns the pointer to the data, and the last is the subspan with the parameters offset and count. Subspan returns a subspan starting from offset containing count elements. So while spans have a subversion, can be called like that, string spans, and which I'll cover in this example, as I combine it with z-string. Z-string is a char pointer in disguise. It is basically a zero-terminated C-style string, and its purpose is to distinguish C-style strings from a pointer to a single character or character sequences. It has other forms as well, like CZ string, that is a constant char pointer, and WZ string, that is a wide character type. So in this example, I use the system call in Unix-like systems. To get the current working directory, I have a buffer, and I call then the get the current working directory, which will return a pointer to the string literal that is the current working directory. It gets an output parameter, the buffer where the current working directory will be stored, and the buffer size. So then I can pass it to the string span without providing the size. So I convert it to string and print it out, and I can do other things with that fourth topic is the contract support. With contract support, we can express pre and post conditions. Preconditions can be stated with if statements and asserts, but it makes hard to distinguish from ordinary code, and it is hard to update. And with GSL 6 packs, we can express preconditions. So, in the case the conditional value is to false, std terminate will be called. Here we have an example. We have a constructor of the node, and I don't want the name to be empty, so I wrote expects the name not being empty. So if I pass the node's name an empty string, then terminate will be called. Let's see its sibling, ensures. With ensures we can express post conditions, and it works the same like expects. Unless the condition is true, the program will be terminated. In this example, we want to write our own sort algorithm. We sort the array, and to make sure we work that our sort function worked as expected, we call ensures. And inside ensures, we check if the array is sorted with std sorted. If it returns false, then our program will be terminated.
So that's a more diagnostic if the program is terminated.
Yeah.
So you know that it was terminated because of this statement.
Yes. Yes. So if the condition is false, then the program will be terminated.
But will it print something like white terminated or not? Like, does it print a line where it crashes and stuff like that? Which contract was breached? That was the question. Does it print which contract was breached? If you have multiple contracts in can you pinpoint which contract was the issue or not?
I really don't know the answer. Could you help me out? Okay, then I will look after it, and you can give me your email and give you the answer. Yeah. So a little off topic, since C++ 20, you'll get the contract support, and it looks like this. They will be used as attributes. We will start by writing expects or ensures, then the contract level, which is optional, then the expression. Well, the contract level can be either off, so no contract will be checked. Then default can be provided. The default contracts will be checked, and the audit with which the default and the audit contracts will be checked. So I found an example here. So I have a function f, and I expect the x to be greater than 0. If I pass 0 as an attribute, then terminate will be called. So there's an example for ensures. Upon exiting the g function, if the pointer is null, then terminate will be called.
Do we know when these attributes were actually called? So before calling the method or after entering the method?
Expects before and ensures after.
So if expects fails, we actually don't call the method. It's before calling the method.
Yes.
Do we care?
Not really.
Sometimes.
That's an implementation detail.
Because if you call the function, if you have side effects, then it will change the value.
So you
Expects will be expects will definitely be called before entering the body of f.
Yes.
But it doesn't matter if it's called before you actually make the function call, or it's called inside the function call.
Well, you could have parameters that are called from other methods.
Yeah, or
Or they called or they aren't called. So if you don't have just a variable as a parameter, you have as a parameter another function call. So you want to know what actually gets called.
Yeah, concept, a contract within a contract. No, because it's another function that has another contract that is called there.
Yeah.
Nice. Presentation topic for next time.
Well, and we arrived to our last topic, convergence. There are two functions in the GSL that can help us narrow, or better say, to convert one data type to another. These are narrowcast and narrow. Well, what narrowcast does is basically performs a static cast, and the name comes from the states that data loss can happen. So here we have the diagram. Narrowcast gets an object of type U. The static cast is performed from type U to type T, and the object T is returned. Let's see narrow that is similar but is different from narrowcast. Well, you have the U type object. Static cast is performed just as in narrowcast. So your object will be converted from type U to type T. Then another static cast is performed from type T to type U, and this new value will be compared with the initial original value. If they are the same, then the T object is returned, and if they differ, a narrowing error is thrown. So it was GSL, so where can it be found? I recommend using the GSL from Microsoft GitHub page, and the GSL is a header only, so all you have to do is include it in your code. For Visual Studio, it is available as a Nugget package, and if your code is built by using CMake, then GSL from Microsoft supports CMake as well. So all you have to do is include GSL CMake list.txt into your code. But Microsoft's implementation is not the only one. There are more alternatives, such as Marty Mönch's GSL Lite, or Mattia Basaglia's has this Melanolib library that has GSL implemented, and the last is Vicente Scriba's fork for compatibility reasons. As I mentioned tooling earlier in the presentation, if you're using Clang, then you have Clang tidy that can check if your code has followed the rules of C++ core guidelines. For Visual Studio 2015, it is available as Nugget package. It's called Microsoft CPP port check if you're using Visual Studio 2015. And since Visual Studio 2017, it is included by default. But unfortunately, GCC doesn't have the support checker built in.
Is GCL available in Clang tidy?
Yes.
Since when?
I don't really know since when, but you can enable code checking.
You can do a lot of stuff.
So you can do it.
Yes, we've used it in
And it doesn't mean
an
like the one
internal
that
project.
was released yesterday. Like I think for 3 versions. For
I checked last year and it wasn't there. Maybe I didn't check.
Well, I used it 2 months ago.
Okay, so that's good.
Yes, and as a summary, let's see the pros and cons of using GSL, so you can consider using it or not. Well, it supports modern style C++. It has pointer safety, as we've seen with the owners and the not null. It gets rid of C-style programming with the Z-string and spans, and safer code, so less undefined behavior with the contracts and the spans. What are the cons? That since C++ 20 is on its way, it will make some helpers obsolete, such as spans, since there will be spans in the new standard, and track support as we covered earlier, and usage of some helpers reduce effectiveness, such as narrow, because it creates branching, and the last one is that it has a really poor documentation on the most helpers, so you have to experiment yourself. You have to look at the implementation to find out how it really works. So that was just in a nutshell. If you have any other questions, I will try to answer. So if there aren't, then thank you for your attention.
Okay, let's get started. So the random fact of the day has nothing to do with the presentation, apparently. How many of you have had data races in their work experience? 2, 3, 4. Okay, I assume the rest of you haven't had data races. Well, it's a sign that you've grown up in C++ if you have a lot of data races. Today I had 3 data races on my code that I was working on. It's extremely frustrating, extremely annoying. So today I'm extremely nervous about all
It was your code or it was inherited?
Inherited, not my code. It was preventing me for doing my work. So I look afterwards at the videos to see how am I doing while I'm nervous. So know thyself. That's the keyword for today. Okay. Data-oriented design and performance. I'm going to do a lot of coding. So everything that you'll see here is on my editor, nothing else. I don't have any other slides. So these are just my slides. So let's start with the code. I'm trying to build a small application that just has some game objects, in my case dots, that are just moving into the scene. And each dot has a position, direction, some other attributes, and in each iteration I basically change the direction of the dot with some constant angle. Actually, if you look very closely, you see that the dots are spinning in circle. Just because I'm just adding the same thing over there, so it just rotates. So that's the application that I'm trying to do. I'm going to write it the way people are typically going to write that application. And then I'm starting to improve on that and see how best, how we can optimize this thing. Okay, so that was just for show. That's my problem. I'm having 10 million points. My world has a size of 3000 per 3000 pixels, and I'm only viewing a rectangle of 800 per 800 pixels. Just the first 800 doesn't really matter. Then I have the max velocity. Does it make sense? So a lot of points in a very vast world, and I'm looking at just a small portion of that world. Let's run the application. And that's my starting point. That's what I'm trying to optimize. I'm not sure if you can see over here. It tells me the frame per second, so it's 5.7, and the average frame time, which is about 174 milliseconds. Right? So it takes 174 milliseconds to draw one frame. Right? You make the inverse and you get the frame per second. This cannot be anything close to something that's playable, so like a game. Okay, so let me just walk through the main parts of the code. So I'm having a vector of 2 floats, that's it. I'm having a function that gets, are you all seeing okay?
It could be better, but it's okay.
You can come forward, there's a lot of places. I'm having a rotation matrix. This is where all the important math is going to, which basically is just a cosine and the sine of the angle. That's everything that I'm storing, so I'm not storing the full matrix. I can have a rotation matrix, a function that gives me a rotation matrix for an angle, and just constructing it with a cosine and the sine. And then I have a function that rotates a vector, so if I give it a matrix, and the vector, it will just rotate it. So this is essential. This is called each frame multiple times. And you can see I'm not doing any trigonometric function in here. So I'm just doing the multiplies and addition and subtraction. Okay, I'm having a function to draw a point. That's my game object. And this basically checks if my point is within my view side. So I'm just, again, I'm using the top left, or the bottom left, whatever. I'm just checking in the first part of the range. If both x and y is in that view range, then I'll just draw the point, doing some scaling over here for some reason. I forgot the reason, but that's what I'm doing. I'm having some more. Okay. The way people are tempted to write this is to have some kind of a base class, in this case iGameObject, which has an advance function. You call it each frame to advance your game object, and a draw function which just draws it. My actual game object has a position, a velocity, a name, a model, pointer. I don't care what's that. I have some other members, I don't care, and then I have some accumulator which just does something, whatever. Constructing it, in the advanced thing I'm receiving a rotation matrix, I'm doing the rotate, and I'm changing the position. If you notice here I don't have any trigonometric functions, right? So those are called once when I compute the rotation matrix. And for drawing, I'm basically checking whether I'm in range, and I just draw the point. I'm doing the check kind of twice, but that's irrelevant. The compiler, or yes, the compiler can rule that out. Okay, in the world I have a function generate random, which generates random things on the screen. Doesn't really matter. I'm having an advance. Again, the rotation matrix is given. So I'm just iterating over all the points and I'm advancing them all. So while I'm advancing the whole world, while I'm doing the calculation for the next frame, I'm not doing any trigonometric functions, right? So just multiplies and additions. And then drawing, of course, that was not supposed to be visible. Okay. I do this, nor this. Okay, that's good. Good. So is it clear what I'm doing? So I'm having the advanced thing, which just does some multiplication, additions, and changes the position of all the points based on their current velocity, and the draw, which just draws the point on the screen. Now I'm having a world. And in main, I'll just initialize something. I'm just creating my OpenGL application, blah blah blah, boilerplate code, and the whole thing happens in this display one frame. So let's just step through this. So I have a rotation angle which I start at 0. It's static, so each time I'm entering that function, it will retain its value, and each time I'm entering, I'm just adding 0.01 to it, so I'm changing the rotation angle each time. I'm advancing the world with the with a rotation matrix which is calculated here. So at this point, this is the only place in which I actually apply one cosine and one sine. That's the only place. And then inside the advance, while I'm iterating over all those, how many million points? 10 million points, I'm not doing any cosine and sine. I keep mentioning this because, as you know it, those are really expensive. So I'm trying not to play any tricks here. Then I clear some color, blah blah blah. Then I just draw, right? And then the and flash OpenGL stuff, and then here's some code to compute the frame time, and based on that, the FPS. Questions so far? Does it make sense what the program does, how it's implemented? What's kind of the execution profile? Okay, good. Now, let me run this again. So 175 milliseconds, that's my frame time. That's obviously not okay. What's the problem? Where's the bottleneck?
Memory, scattered objects through memory, and so that all of them are allocated with new. So any
You know too much. I'm not.
Any game developer would.
I'm not taking any answers from you. You already know where I'm going, so I'm not taking answers from you. Anybody else?
Computations, too many computations. Maybe some redundant computations. I mean, you have a lot of points you want to move, and maybe you can divide them in points having the same directions. And all of them would use the same advance.
Okay, so you're saying that the actual problem is in the advance function.
This is one of them.
The next one?
I think that when you're comparing it, if it's inside the screen, to know only if a few of them would pass, and you're essentially doing that computation for all of them.
Okay, so you're saying the drawing is the problem.
No, when you check if it needs to be drawn,
If you look at
then those are branches.
So if you look at the if, that's few cycles. If you look at the memory to bring them, that's several hundreds of cycles.
You know too much.
It's an order of magnitude memory access compared to an if.
You're true, but let's get to that later. So for now, we have this debate whether it's the actual advance who's causing us problems, so the computations, we're doing a lot of computation, or you're saying it's the if inside the draw.
Can you show us again the draw function, please?
Yes. So the draw for the point is this. If I'm inside, then just draw point, which does another if for some stupid reason I don't know.
You can remove one of them. It should be half.
Yes.
No,
Now it should be much faster, right?
no.
Why? 176. It's the same. Okay, that's not it.
So
Me
is
too.
this debug or release?
It's released. Of course, it's released. So,
Just asking.
yeah. Okay, let me go one step further and say the problem is with the other if. I don't have an easy way to comment out the other if, so I'm just commenting out the whole thing. So I'm just basically not draw at all. I'm just updating frames. So I'm trying to guess whether the bottleneck is in the advance. Oh crap, I forgot to compile. It's not drawing anything, right? So don't expect to see the dots.
Help a bit.
Just it's still the same thing. Let me go the other way and also comment out this one. So I'm just not drawing anything. I'm just not calling the empty function. I'm just not drawing anything.
Actually, this one should improve a little bit because you don't have a virtual function call and the memory access.
It helped a bit.
It does.
Not too much.
It's 110.
Not
so
as expected anyway.
not as expected. Okay, so the problem is definitely what you said. The problem is in advance. Let's do the other test. Let's just uncomment those things. Undo. It's okay, and I'll just go in the big advance, and I'm saying, okay, don't advance, just draw me the same thing over and over again.
110?
The difference.
A little bit better.
It's better.
Not much.
Not by much, but it's better. So, yes.
I see you do a lot of copies when calling those methods, advanced and call.
Okay, what copies?
That would be the issue.
So first, we have here 66, right? It's pretty small, so just wanted to make sure. It's kind of, I'm doing, by removing any of these, I'm doing some optimization, but none of them is the bottleneck. So somehow we have a problem there. And you're saying that we are doing a lot of copying, right?
Yes. For example, in advance, the rotation matrix parameter. It could be a construct, perhaps.
Okay,
In the
let's make
end,
it a construct.
Two
Rob-
floats and the memory address on a 64-bit machine is the same thing, so
Yes, exactly. But let's do that. So,
two floats in the structure and the address of the structure, so you're copying 64 bits in both cases.
and I have to do it in here as well. Okay,
You have to change them in the object and the interface.
I don't want to show you the other code.
Okay.
Oh crap, I'm doing the wrong thing, sorry. It's my mistake. I should not change the advance here. It's okay if I just change this. It's just the word here. This one is the only one that I've changed, right? So I'm not doing any copying here. The other advance is not called. So now it should work. It's the same.
It's called only once per frame, right?
Yes.
So it's nothing.
Even if I call it multiple times, I'm copying exactly the same thing. Actually, depending on the compiler, I may get things even worse because I'm doing them in direction. So the compiler must go and look at the memory at that point and just go back. Typically, compilers will optimize that, but okay. So that's not the problem. Where is the problem then? Let me just. I cannot comment on both of them. It's just it's silly, but then I'm not doing anything. So the problem that we are having here is we have way too many game objects. And that's our problem. We cannot do that. We cannot change that, but we can change how we manage those objects. We can change how we access them. And one option is to get rid of this bloody inheritance in here because it doesn't help us. I mean, typically, I should do another talk another time about inheritance is pretty bad. Inheritance is the base class of evil. Please remember that. I'm not going to talk more about this, but inheritance is the base class of evil. Okay. what I'm going to do, I'm going to switch to my next implementation, classical pen flat. I'm just going to collapse this just to make it easier to see. So I'm having the same game object, it's exactly the same thing, but I'm not deriving from anything. And the world is just a vector of game object. Let me go back, I forgot to mention one thing previously. So the world is a vector of game object pointers, right? So they are scattered around the memory. If I need to traverse them, I have to go this way, that way, the other way, all around the place. In here, with this implementation, I just have all the elements in my array. So the advance for the world will be exactly the same. The draw for the world will be exactly the same. I'm just not using pointers, right? That's the only change I made. Let me compile it. And it's 138. Was it better? Yes, it is better. It was 170, right? That's where we started from. And kind of, we are somehow halfway, not quite halfway through, but we are getting towards 100, which would be the middle. So we are making progress. Now, is it clear why this method is better than the previous one?
You don't trash the cache.
Yes.
We should say faster, not better.
Sorry?
We should say faster, not better.
You're right. It's faster. In this context, faster is better, right? So let's just make an agreement here. In this context, faster is better. Better equals faster. I mean, you cannot deliver a dots game with 5 FPS, right? Now I'm having 7 FPS. You cannot deliver with 7. Okay, is it clear why it's faster this way? Okay, what's next? Not you.
Cache line size.
Not you. What's next?
You have that game object in the vector, and one game object has more stuff in it than just the things you need for advancing.
Well, I'm having more things that I don't need here. I'm going to need them in other parts of the system.
So use different arrays, split. For example, coordinates in one type of array, the rest of the properties in other arrays. So do arrays of fields, not arrays of structs. So
Okay.
Yeah,
Is that the same thing what you're saying?
I think so. I can like extract all the, I guess just the coordinates that you need for advancing into an object or whatever, and have a vector of those that you iterate for advancing, not the whole of something.
I think it's the same with what he said, yeah. Any other ideas? No? Let's try this one. Luckily for us, it's exactly what I've written below. So we don't have to make any changes. So what I'm doing now, I'm going to shift around my objects. So I'm having my other game object data, so things that I don't need here, and I just put it into one class over here. And then I have my world, which instead of having a vector of one big structure, I'm having multiple vectors. So this is called a structure of array, as opposed to array of structure. Previously I had a vector of a structure, now I have a structure of vectors, right? So structure of array. The thing that I'm doing here, I need to slightly change the advance and draw. I'm doing the same thing, but basically I'm going to just manually inline the function calls in here, just because I have the vectors here. I don't have an object to call, right? So So I have to do that. But essentially, it's the same thing. I could have done that previously, and I would have got exactly the same performance. The compiler is pretty good at inline. And for draw, basically, I'm doing the same thing. I'm iterating, and I'm just drawing. Okay. Whoa, 29 milliseconds and 33 FPS. At this point, we can ship the game if it would be just that.
It's Friday, it's good enough.
No. That's Monday.
For mobile, maybe.
Sorry?
For mobile, maybe.
Yes, for mobile, maybe. So we achieved a great thing here. I just want to make sure that everybody's clear with what we were doing here. So what we had so far was a big vector of a vector of big structs, and then we have to go through all of them to get small portions of that data. If you look at in here, I'm having two floats here, 32 bytes here, 64-bit pointer here, and another float here. So I'm going to basically have one cache line filled with this object. That means that each time I need to access the object, the CPU must go to the main RAM to get that information. Getting to the main RAM is extremely slow. It's something like 200 times slower than addition or something like that, than a small instruction. Right? So we are wasting a lot of cycles just to go to the memory and fetch some data. If we just reorganize this and have our positions in one place and our velocities in there separately, and each time I need to get a position, I'm going to take one part of the cache line, but the cache line is there with multiple positions. So position is how much? 4 plus 4, 8 bytes. My cache line is 64. So I'm having 8 positions per cache line. That means that I can access positions 8 times faster if I'm just organizing this way. Make sense? It's a little bit mathematic intense.
8 by 8, the 8 by 8 part.
Sorry?
The 8 by 8 part.
Yes, that's the hardest part. That's why I went into computing, not to do calculations by hand, right? That's why we have computers. The other one is simple, 8 by 8. I have to think about it, how much.
Why are you having separate vectors for positions and velocities?
Because typically I'm accessing them differently. In here, I'm using velocities and positions, right? So I'm accessing them both. But in here, I'm just using positions. So I do not need to go to read the velocities if I don't need it. But just to draw this thing, let me actually do the following. Let me just comment out this. So that's 9 milliseconds. So to draw all those points with all those if checks, I'm just taking 9 milliseconds. Just because I can iterate pretty fast over my RAM.
And what's the rest for the other thing?
Can you guess me how, what would be the timing for that? So 9 milliseconds is just drawing. What would be the time for updating?
20?
Sorry?
20 and 15.
I said
20, 15, okay. It's slightly different, but yeah. 22. So it's kind of doubled, right? Roughly, but it's kind of doubled because I'm doing twice the memory accesses that I need. How many actual draw calls I'm making? Exactly the same, right? So I'm just making a very tiny part of draw calls because I have very few points which are in my viewport, but I'm iterating over all the objects. So the main bottleneck here is the memory iteration and not necessarily the...
Yeah, but you're preferring making the second one faster instead of the first one.
It's the same thing.
Like
So-
if you would merge the two vectors into a single one, you would make the first one faster and
Why?
the second one slower, right?
Why? I'm just using exactly 100% of my cache line. Why would it be faster?
Doesn't, like when you access velocities of light, doesn't it like bring into the cache velocities of light plus 1 equals 2 and everything else that follows? And when you go for the positions, you need space for those ones, so it might...
It doesn't have it because I have L1 and L2 cache. But let's try it out. Does it make sense, my explanation?
Yeah, sort of.
Still, let's try it out. Okay.
I have to change the type for the vector.
I have two reverse. Ah, I just copied one. Okay. Hope it will work this way. Looks okay. That will be just... I'm not sure why I keep the commented stuff out because I'm going to... That's velocity, right?
Yeah.
The actual.
26.
So slower.
Slowly.
Why is it slower?
Because it's not used in the velocity in the drop function, I guess.
It drops a little bit, so it's 25. Maybe it's just a measurement. By the way, all this is kind of rough, right? So don't expect this to be extremely accurate. It's just, it's kind of the same. So I would just, at this point I would say it's a measurement error and not worry about it. But definitely I would do some more experiments with that. But does it make sense why it's not faster this way? You're using exactly the same memory, right? It cannot be faster. So the goal here, if we say the memory is the bottleneck, then the goal here is to not waste our memory. If we read something from RAM, we need to use it. Please.
Then you should inline the draw.
It's already aligned.
Like right after you draw, right after you advance, you draw. You don't iterate over the whole objects twice.
the GPU will be the bottleneck there because it stalls if you draw it while updating. It's a more complex thing.
That is true. Yes, that is true. We can do that, but for the sake of argumentation, let's say we are not allowed to do that because in a game, typically you update everything and then you just draw everything at the end. You don't want to mix those things up. But yes, it can be an optimization to not go over the memory twice. That is true. Let me check once more. 23. So there's a difference in there. I need to think why. Now you gave me a problem to solve over the weekend. I hate it. Okay, let's do one more thing. Let's just draw here. I'm not sure if I can, but let's just draw it. 18.
It's more. If you mix GPU with other computation, it stalls the GPU. It's a weird thing that happens.
Yes.
That's why in games you update everything and you draw everything at the end.
Well, one reason for not being able to do that is I need to do something before drawing. So, yeah. Whatever. What did I do? This one. Okay. Make sense so far? So, we are stuck with this pretty smooth movement, 30 milliseconds. The problem is this is still not enough. What else can we do?
We can do the advanced with seams instructions.
That is true. That would speed up us a little bit. I haven't gone that way, and I don't want to do it now because I don't know how to. I just have to look up the manual. But yes, actually, I don't think that would be an optimization. I'm pretty sure it's already done.
A little, but not much.
No, it will be something, but I'm pretty sure it's already done by the compiler. So I know Clang does this a lot.
Mm-hmm.
I've seen it do it so many times in places I wouldn't expect that I'm extremely convinced that it's going to do it this time. But yeah, that's a potential idea. First, I would have to disassemble my result, see what Clang did, and if it didn't do that optimization, then I have to do it manually.
I think you have dependent instructions there. For example, the addition must wait to finish the computation of the velocity. So if you compute the velocity before, might be an optimization because the instruction can be done in in multiple. See the actual velocity is so you cannot do the addition before the actual velocity is finished.
Yes.
So in the pipeline, in a complex pipeline like Intel CPU has many instructions are done in parallel. They don't wait the previous instruction to finish before it starts the next instruction. But here you must wait for the rotate to finish because you're using it in.
Okay. How can I change this? Actually, this code.
I think it's quite simple. If you move it outside, you move it outside. You make 2 for loops. One to compute the velocities.
Yep.
Something like that. But you have to save somewhere the velocity.
Where?
You could do something like you calculate the velocity for the next object. And you use it in the next iteration to apply it to the previous object.
My head. I'm thinking about loop unrolling.
So, my experience with it, please don't take my word for it, just look it up every time. I think 10 years, 10 years up to this point, all the compilers have it. And all the compilers can do better than
Okay.
you. So just stop thinking about the paralleling. It's not an optimization anymore, not something you need to do by hand.
I think you can store the actual velocity in velocities instead of.
Nope. It will change the mathematical model behind it. You see, I'm never changing the velocities.
Can you show me exactly how do you do the rotate function?
Yeah, I was thinking the same.
Rotate.
Back to either structure or class. Back
Sorry?
to is
What was the difference between a struct and a class? Sorry, that was a bad
is there
joke from my side.
is there construction being done there?
No,
Okay.
I mean,
So you're going to
it's just there is no difference between a struct and a class, and everything here is just inlined by the compiler. So you don't care. It's just it's the optimal code that you would write in C for this.
So let's get back to rotate.
So basically, at each frame, you take the original velocity and multiply it with this guy,
Yes.
and you want to keep this behavior.
Stop thinking about micro optimization. This is not about micro optimization. I'm having exactly one thing, one strategy that I applied every time, and I'm always looking from above, from a high level perspective. I'm not looking into small stuff. I haven't mentioned exactly the principle. Actually, I did. The principle is something like, if you get something from memory, make sure you need that thing from memory.
So you're going to split that data again somehow.
Sorry?
You're going to split the data again somehow.
You've been cheating.
I'm just supposing.
Yeah. Yes, so the main idea is the following. I'm doing a lot of, you want to say something? Sorry. Come, try. I thought I had more time. Sorry, need to rush up. So the main idea is the following. We have 10 million points, just a few of them are on the screen. We don't have to do all the computation all the time for every point if we just know that we don't have to display them.
But actually, we have to, because we change the behavior. If we don't do it, position change, so we have to simulate them even if they are not on the screen, because they might get on the screen.
But we
Later
can
on.
increase the velocity and use it when we can know when the point is on the screen. So we don't change the position, we only increase the velocity, and then check if the position plus the velocity moves you to a position inside that viewport, for example.
Yes, something like that. That's the main idea. I'm going to skip it fast through this, so please excuse me if I'm just. I want you to follow every lead that you had to just go there and see what happens. So I'm just going to go to this one. The main idea here is we have exactly the same structure, but the advancement is more complicated. I need to explain this first. So I have 10 million points, but some of them are near to my display board. I'm not saying necessarily inside the display, I'm saying near. So I have to have some way of saying this point can potentially be seen in the next 10 seconds. Right? And some points are pretty far away, and I'm sure that they will never be seen in my frame in the next 10 seconds. Right? So I'm having this logical partition between the data. Then if I'm doing that, then basically I can split the data inside my vectors into the near part and the far part. And I'm keeping this end of near, which is basically an iterator in the C style, sorry for modern C++. It's just an iterator over that to tell me where the split between the two things are. Right? And after I'm generating the random number, I'm just going to call a range data, which will basically split my thing into the two parts. And then I'm having advanced split in two parts. I'm iterating over until end of near, so all the points that are close to my viewport, I'm going to do exactly the same thing. And rarely, I'm doing this every 100 frames, so that is if I'm assuming 30 frames per second, that is every 2 seconds, something. That is hard. Right, so I'm doing every couple of seconds, I'm updating the rest of that. And for this particular problem, I can make sure that I'm doing exactly the same computation as I did before by just having some formula. So the final position, if I would do the same, the iteration over the for each frame, it would be the initial position plus what is V? Velocity times rotation 1 plus velocity times rotation 2 plus velocity times rotation 3, or position 0 plus velocity times sum of the matrices, or it can be V times the sum of that thing, right? So all I have to do is keep that sum. I don't have to iterate all the points, just need to keep that sum, like how am I going to update the frame? So I'm just keeping the aggregate of that. And then, so I'm going to do that every frame, and then, so this is every frame, and sorry, this rotation mat sum is the accumulation of the rotation matrix, and every 100 frames, I'm going to update all the points, right? So, is everyone convinced that I'm going to get exactly the same results, mathematically?
Is that frame very slow?
The frame is...
Frame, when you update everything.
Well, it is as slow as my previous frame.
Maybe the player will feel that
Yes,
slowing down.
that is true. And I was planning to discuss more on that a little bit later. That is true. That's a weak point of this strategy. But from a computation point of view, does it make sense? Is it the same?
Yeah.
Okay.
But for this case, it's okay. But if you add the functionality to move your viewport with mouse or keyboard, how would you calculate those faraway points? Would you calculate them when the viewport moving function is called? Or?
I would place the same discussion in the discussion regarding this frame. So bear with me for a moment. Now, if I'm doing this split between near and far, then my draw is just the same thing, but I'm just iterating over that, right? Range data is doing this way, and I'm just for my particular example, I just choose that near is 4 times as big as the screen size, right? So it's plenty enough to just go there, right?
Why not use this partition? Sorry. To partition the points.
I had a reason, but I forgot. I think it was something related to his near view.
You can pass a function from.
Yeah, but then I had to do 3 times. I'm not sure. Maybe you're right. Maybe it's the same thing.
I'm just curious.
So just
Okay.
it's a partition, yeah. Okay, guesses. How fast is this version?
It depends on the partition, but probably several times faster depending on how many points you have in the near and how many points you have in the far.
Yeah, depends on how many points are in the port that you're not computing in that frame.
I don't
So
know.
4 times the view size. View size is 800. The wall size is 300,000.
300. Okay, so
Both of them
a
are
lot
outside.
faster.
How fast?
Yeah, a lot faster.